Hello everyone, this is KinCony Home Automation Training Lesson 7. How to wind with the digital output. So in this video, I will show you how to connect a load to the digital output part. Because you can see there are A and B, and usually we will have used by the relay and MOSFET. So the relay is mechanical version, so that is controlled open and close. And the MOSFET is controlled by electronic device. So in this video, I will show you what is different between these two cases. And let's look at this have two cases. The first is relay. You can see maybe have some relay on your PCB board. And the relay is very easy. Maybe have a COM and normal open and normal close. And the simplest you can see that just use a COM and normal open, so that we can control this load on and off. So you can see if you use a relay, you can input AC 220 volt into your load, and also you can use this AC 110 volt to your load, and also you can input, you can see control 12 or 24 volt or other volt to your load. It according to your relay requirements. You can see at here, every relay will show at here what's max ampere and max work voltage. So you can check in your label a print on your relay. And this first is relay. So this is mechanic, just a physical close and open. So that will be very easy. Used for AC load or used for DC load. But next you can see the second, you can see the MOSFET. The MOSFET is this electronic component that only control DC load, can't use for AC load. So you can see we can look at two PCB board, and you can see this one, that is A16 V3 board. You can see that is this one is MOSFET. So it's 16 channels, so that have 16 MOSFET. And this is output, you can see this is 1 to 8 channel output, and this is 9 to 16 channel output. Because these two output terminal is the same principle, so we can see only this one. 8 channel, this have a COM, this have Y1, Y2, Y3, Y4 until Y8. So we can look at our PowerPoint. So you can see this is a MOSFET. That is, this G is controlled by ESP32 pin. And this one, you can see the D is go to this load, and the S, that means input your power supply. Neither use the 12 volt, but also you can use this 24 volt. Let's look at the schematic of our KinCony A16 V3 board, and you can see this is A16 V3 board, and let's just look at the output circuit. So you can see this have 16 channel MOSFET output, and everyone, you can see every unit, because every unit is same. So we can look at this one, this first channel 1, this have a optical. You can see this controlled by ESP32 pin, and this output and go to this MOSFET, and this just a LED indicate for the load. So this Y1 is output, and this L you can see this LO, that is input of power. If you want control 12 volt load, so use this just input 12 volt. If you want control 24 volt load, you just connect with 24 volt. And so this is a control unit. So you can see in our PowerPoint, just this one, but this time you can see that have 8 channel. So you can see this 8 MOSFET have connected together. Just the S is connected together with this L. Just this terminal L, just this terminal L. That's this one, you can see. Just this, that have printed 12 volt, but also you can use 24 volt. So this is L, and you can see it here. This is L, And this Y1, Y2, Y3, Y4 until Y8, that is output, just output to your load. So this one, you can see Y1, Y2, Y3, Y4. So you can see this grid terminal is for user to use. So you need to connect with L and connect Y1, Y2, Y3 to your load. Maybe you have connect a DC motor, and maybe you have connect a valve. So you can connect any DC load by this Y1, Y2, Y3, Y4. But this is very important. You can see these sections, how to connect your load to your Y output, what current need to note, need to understand, and how to choose. Because you can see this L that have connect with all S together. So this PCB board have a track that is L go to this all MOSFET. So you can see if you this green terminal, the max current is 10 ampere. So that at this Y1, at Y2, at Y3, and until Y8, this total current must less than this terminal max current. Because you can see that all have connected together with just only one L terminal port. So this current is large because the 8 MOSFET load current have connected have together. So this will have a large current. So just make sure this all Y terminal totally less than this current. Because KinCony use this green terminal that have a max 10 ampere, so you just less than 10 ampere. You can see, for example, this MOSFET have 10 ampere version, and another MOSFET have 4 ampere version. So you can see, if you A16V2, that is 10 ampere, MOSFET max 10 ampere, and you can see this is T64 and T32 and T16M and T128M. That board use this small MOSFET. You can see the MOSFET size is smaller. So this max is 4 ampere because the 64 channel is very large number of this channel. So we want this board become smaller. Will save your space of your power distribution box. So we have choose this 4 ampere MOSFET, but this is enough for you use because this output to the terminal always connect a contact, DC contact. So the DC contact can control large current load. So this 4 ampere is enough. So you can see this is very small, and this one 10 ampere is very big. So this one that can drive your large current load, DC load, and this one just can drive your DC load for low current. If you want large current, you can connect externally or external DC contact. So you can see, for example, the first one, you can see if you use this board, max is 10 ampere MOSFET. So if Y1 is 5 ampere, Y2 is 2 ampere, Y3 is 2 ampere. So this added together is 9 ampere. So you'd bet let your 4, 5, 6, 7, 8 don't connect any load. Just make sure the max current is less than 10 ampere. Okay, you can see if the second example that Y1 is 2 ampere, Y2 is 2 ampere, Y3 is 2 ampere, Y4 is 2 ampere. So this can add together is 8 ampere. So make sure your Y5, Y6, Y7, Y8 have a smaller current, just not greater than 10 ampere. And next you can see the three case that is Y1 and until Y8 all is 1 ampere. So this can add together also is 8 ampere, so that is less than 10 ampere is also okay, no problem. So this have different, compare this different current together, just to make sure you less than this terminal max current. Because if you all load is turned on together, So this terminal, this L, have a large current. If you can make sure your all load will not turn on at the same time, so this can let some current large, no problem. Just make sure how many channel output will turn on at the same time, so you can calculate this total current less than the max current. Okay, so this is important because we have designed this MOSFET channel used by this thin common L terminal port. So just make sure this way don't less than this one. So that will be safety and security. Okay, this is how to use this digital output for relay and for MOSFET. If you have any questions, you can leave a message to us. Thanks for watching.